Good morning, students. Today I welcome you all to this uh, computer graphics and lab visualization lab program. I'm going to explain that is program 4. What is this program is going to do? It is going to draw a color too, and here we are the user is able to move the camera suitably to experiment with the concept of perspective learning. So this is what is a program we are going to solve. Now, what is perspective projection or perspective use is all about? See, normally whenever we want to create more realistic looking scenes, we use the projection that is called as a perspective projection. See, what is perspective projection all about? Suppose I have an object that is very near to me, it looks very larger. Similarly, if I have an object that is very far from the viewer, it appears smaller on the screen. So this effect, the object which appears smaller on the screen, it's called as foreshortening, or we call it as a foreshortening. And another name for this perspective projection is also called as natural view. What exactly we are going to have. It so happens the view volume, whatever it's created for a perspective projection, is something like a frustum. What is a frustum? It's like a truncated pyramid with a narrow end towards the user. So normally, in order to make this infinite, see all whenever we have see normally whenever we want to get a projection, we have three concepts here. One is viewer, then the view volume, and finally the object. In between the object and the viewer, there is so called as what is called as the projection plane, or which is in 2D it is called projection plane. In 3D it is called as the view volume. So here the view volume is truncated pyramid, and that truncated, how are we obtaining this? We are adding two planes. One is a front clipping plane, and other one is a back clipping plane, with which we are able to get what exactly it is. Okay, so that is what is a. This is how exactly the projections look like. Now, what is a how do we represent that in case of OpenGL? In OpenGL, there is a function called as GLFrustum, which has 6 parameters, and xmin and ymin corresponds to the x-axis, ymin and ymax corresponds to the y-axis minimum and maximum value, and z near and far corresponds to the z-axis value. How near you are to the center of projection, how far you are towards the center of projection. So normally these values should be always greater than 0. And what are these near and far are the from the center of projection means this value is like something like the threshold you have kept. Once you cross this, your object get disappeared. That is what. So projection plane is always orthogonal or perpendicular to the z plane. So as you all can see in this diagram, we have x-min, y-min, x-near towards the front clipping plane, and x-max, y-max minus z-far towards the back clipping plane. So in between the the frame, what exactly you are able to look is, see, in between this blue one and the light blue one, this area is what is called as the frustum. This is called as the frustum. Why are we adding these two? See, the lines are infinite in nature. To make it finite, we need to add these two planes with which we are able to get this point. Truncated pyramid. This whole region is what exactly called as the truncated pyramid. That is nothing but a frustration. Now, how do we get this? Already I've told this is what is another way of setting up this is left, right, bottom, top, near this is what is a thing. Next, we have another function called as, normally whenever we want to provide a camera position, we use what is called as look at function. So what is the purpose of this look at function is, the look at function is used to position a camera with the eye pointing towards the camera. That is E plus E is nothing but the camera position. The camera position to a look at desired function. To a desired function. AX, AY and AZ corresponds to the desired function. Next, UX, UY and UZ correspond to camera up. Whenever I want to focus on an object, I should make my camera to be focused towards what? Up direction. That is UX, UY and UZ. That is what. So this is how exactly the camera looks like. All of you are able to see this. This is where I am focusing the camera. So E is nothing but the camera eye, what exactly my eye is focusing on the camera, and I'm interested towards or desired. This is my object. I want to focus. So it is AX, AY, AZ. And now whenever I want to focus an object, my camera should be facing towards which direction? Up direction. So this corresponds to up X, up Y, and up Z. Now in this program, we have used another concept here, that is nothing but the keyboard interface. Now what is this keyboard interface is all about? Um, the keyboard interface is done by using a callback registry called as GLET keyboard func, and it should have a callback function. That callback function I'm explaining here. So normally it is void in nature. Key is the name of the callback function I have given. It has three parameters. What is the key you are going to have, and where is it located at that instant of time, that is given by X and Y. So here we are using X, Y to move the viewer. Suppose I want to move the viewer. If I use, see here I have used 6 variables to move it. Whenever I have lowercase x, I'll be -1. Indicates I'm moving towards what? The negative of the x-axis. That is towards the left of this. Whenever I press capital X, the viewer will be able to move towards the positive direction of the x-axis. Similarly, positive direction of y-axis, negative direction of y-axis, and z-axis and the z-axis. All this will be happening towards this. Okay. Now let's move on to the let's move on to the program. So I'll not explain much. Whatever the new concept we have used in this, only that I'll be explaining. Here, what is that I am doing here is, this part has been already explained in the other program. Where all there is a change, I'll be explaining only that part. Now, what do we need for this? We need a viewer, right? We need to focus the camera. That is to be declared here. So what I'm going to use here is let static viewer, and the viewer is located in which direction, which axis? Z axis. At what value? 5. Initially viewer is located at this point. This is 5 is what exactly the location. So is located at positive Z axis at a factor at the point 5. Next, we have another function already I told about. Whenever you want to use a camera, whenever you have used a camera in your program, you need to use what is called as look at function. Already I told about the first 3 parameter signifies the eye of the camera, where exactly you're focused, and next is with the desired position with the camera up. Now look at this. Initially, the viewer value, whatever we have, viewer 0, viewer 1, viewer 2, that is what we have set up. Then 0, 0, it is a desired. Initially, the desired location is at the origin only I focus, and it will be always pointing towards the y direction. So desired at up position. Up is what? Which axis? It is y axis. It is at the y axis. That is what. So this is the function used to set the camera position. Now, what type of view we want for this program? Perspective view. Which function did we discuss to define that? It is by using GLFrustum. All of you are able to see this? GLFrustum -2. So, x-axis is that is left towards the left -2.0. Okay, left, right, towards the right it is 2, then -2 into 8 divided by W. So obviously the height and width corresponds to the size of the window, what exactly you have considered here. By default, it will take your whatever the size of the graphics window you have represented in your program. So this is what is a case that we have. Now, and next is, all of you can observe here, we have very important thing here towards the z-axis. See, that is the near value is 2 and the far value is 20.0. Similarly, -2 and this is what is a 0. This is what is a program we have. So the frustum is going to create a view volume with all this value, with the totally the 9 parameters, and all the object value what you have defined should fall within this. See, when it crosses this, you will not be able to see the object gets disappeared. And another unique feature of this program, as already I explained, we have used keyboard interface here. So any keyboard interface you provide is going to have 3 parameters: unsigned a key, int x and y. This is what is a thing we have. And next is, whenever you take the keys into consideration, you're going to have we have used totally 6 keys. One is x, other one is the capital X. We are of 0 and we are of 1. It is what exactly we are going to have. Y and Z. See, whenever I press the lowercase x, viewer of 0 will be moving in the negative z direction. That is, it gets decremented. It keeps moving towards the negative. Whenever I press capital X, the viewer starts moving in the positive direction. So the value gets incremented by factor of 1. Similarly, for Y and Z, the same thing happens here. These values are taken from this. So this is all about the program. Now it so happens, see, we have the values fixed there. So near and far values, depending on the near and far values, the object appears. As you keep moving away. At one stage, you reach a point called as vanishing point, and your object starts disappearing. So that all depends on your near and far value, how near you are to center of projection, and how far you are near to a center of projection. So this is all about the program. Thank you.